Up, everyone? Welcome to Modern Day Debate. We are a neutral, non-partisan platform welcoming everyone from all walks of life. If you're looking for even more fantastic debates, we are all over the internet on your favorite podcasting platform. So if you enjoy debates, please don't forget to like, follow, or subscribe, including tonight's debate on Flat Earth versus Globe Earth with our debaters Iron Horse and David Velar, here to help us find out. And if you enjoy what either of them have to say tonight, our guest links are in the description below. You can also tag me in chat at Amy Newman with your questions or comments for our Q&A section, though super chats will get your sent to the top of the list. With that, I'm going to hand it over to Iron for their up to 10-minute opening statement. The floor is all yours.
Right, yeah, well, thank you, Amy, and thanks, David. Neither of us were actually the original debaters for today's topic, so we're both at the last minute stand-in. So, of course, as usual, I've got nothing prepared, but I don't really need to because it's all up in here. Pretty much everything that we understand about the nature of reality should be fundamental, should be provable, should be observable, and it should be backed up by evidence. When you believe in something, if you have a belief, like if you believe we live on a spinning ball hurtling through the vacuum of space, then that's an extraordinary claim. And of course, then the extraordinary claim must be met by extraordinary evidence. And there is no evidence to the person who believes we live on a spinning ball hurtling through space. It's the most ridiculous concept you could ever be brainwashed with as a child. But because you are a child, young and trusting, when you're brought up with this, you tend to believe it. And you're taught that the alternative to that model is something else that's also out in space that must have an edge, and so therefore everything is falling off the edge if that's the case. Whereas if you just reject all that nonsense in the first place and just start with the fundamental basics of what we do observe, there is no motion of the Earth. Now, when we look for curvature, we find there is no curvature. If we get up higher, we see further. So the illusion of curvature was limited to these people from thousands of years ago who came up with the idea that we lived on a globe because they saw a ship or a boat disappearing into the distance bottom first, simply because they had no alternative but to accept either they got the law of convergence, which is what we now know to be true, or if they could have gotten up higher, they would have seen that the boat hasn't actually disappeared over anything. The horizon extends out infinitely. Water level proves that the fact that our known Earth is at least 70% covered with water, then that has to be flat and level. That is just the nature of fluid dynamics in general. And all land is then measured as height above sea level. So just because you can't see something doesn't mean it's disappeared behind the curve. So we've got the lack of curvature. There's a lack of motion. The scientists who tried to find motion for hundreds of years all failed. And so all they've done is come up with special theories of relative motion to try and hand-wave dismiss that, because on philosophical grounds, they just don't want to accept the fact that the Earth is actually the centre of existence. We see lights above us. There's no proof that any of them are terra firma. The only possibility that something might be real and solid is the moon, because we see craters and shadows in craters. So that's no proof of anything other than the fact that the moon may also be solid. There's no evidence of all these other planets being terra firma. And I want to stress that, because they base everything on this solar system and everything going around the sun. Water level itself can have a mirror perfect surface on it. Now, that is impossible for water to do that in one place, means it has the potential to be able to do that in every place. So again, if 70% of the surface has the potential to have a mirror perfect surface, then it is impossible then for the land to then make compensation for that curvature to put the Earth into a roughly spheroidal or oblate sphere, as they like to call it, because they know it goes pear-shaped outside of the equator. And that's where all the nonsense began in the first place. Obviously, we get as far as the equator. Oh, Polaris disappears. Oh my gosh, we've descended into the underworld, which is exactly where most religious beliefs have come from. It's all about sun worship. The Son of God goes into the underworld 3 days and nights on the winter solstice, and then after 3 days, it rises again and gives us eternal life. All religious beliefs basically stem around the giver of life, which is the sun. So it's fair enough that, today the modern person still believes that the sun is the center of the universe or the center of the world. Every 6 months, as we're going around the sun, nighttime is looking 100% the opposite direction from where the sun was previously 6 months ago. Yet we still see the exact same stars. Now, yes, some of them change. Some of the constellations might appear in a different place, but that's normal because we know that the sidereal day is the stars rotating around above us is how we measure a year in the first place. And so for us here in Australia, when we look out every single night of the year, that's at dusk, we see the Southern Cross. Now, we should not see that. It should be drifting away if we're going around the sun. Otherwise, the heliists, like the person I'm debating today, you're all helioists. It's a religion. It's a huge cult. You must all believe that the entire universe, at least our galaxy, is also going around the sun. And that's why it's called heliocentrism, because the god Helios, the sun god, that everything is going around, not just our wandering stars, the planets. Everything is basically has to be going around the sun with us, which is just utter nonsense. What we see is those things rotating around above us. They do it every night. It takes 24 hours. The sun returns overhead every day, more or less at midday. It may be on its own slightly elliptical path. Everything can be explained with perspective. Now, another one you'd like to talk about is air pressure. You cannot have pressure inside a vacuum. It's just impossible. A pressurized anything inside a vacuum is the opposite of a vacuum. So the universe or the surrounding space around the Earth cannot be a vacuum, and you cannot say that gravity is a container. Gravity isn't a container. Gravity is a very, very weak force that the smallest little vacuum, like putting your finger over a straw and lifting it out of a glass of water, that tiny little vacuum will overcome gravity down where gravity is the strongest. So how could gravity be even stronger, furthest from the center of gravity? You've got no argument there whatsoever. You cannot have a pressure gradient on a planet. You can have it on a stationary planet Earth fixed at the bottom of the known universe because everything has density and everything finds its place according to its own relative density relative to everything else. I think I'll just leave it at that. Your turn.
Thank you so very much, Ian, for your opening statement. And with that, David, the floor is yours for your up to 10-minute opening statement.
All right. Well, thank you both very much. I appreciate the opportunity to come here, and I'm going to just go ahead and get right to it. I'm going to resolve some of the philosophical and religious misunderstandings. So speaking about Helios and religious beliefs, it does not matter what a religion had taught in the past, and it doesn't even matter if that religion had somehow influenced people's belief one way or the other. That does not mean that the evidence that we see it because there was a religious belief. So that's an absurdity that I agree for a different reason that it's an absurdity. We're not bound to a belief. For instance, a galaxy going around the Earth or the sun, it doesn't make sense that I'm supposed to believe that a galaxy goes around the sun or the Earth because of Helios. So let's knock that out of the way. As far as gravity being weak, so you say, hey, gravity's weak, but because only a small amount of force can be used to overcome it. Well, one, gravity is weak, but there are so many particles that influence the area that the gravitational force is, affecting, that enormous amount of existent particles is why we have the gravitational force that we have. When you compare that to lifting something, what you have to remember is that you're lifting a small amount. And so, yes, the amount of energy that you have is enough to affect the gravitational force on that small object, we are not comparing that small object's potential energy to the entire gravitational force of the Earth. That doesn't make any sense. So that's an absurdity that goes out the window. As far as, gosh, constellations. So you're in Australia and you admit that you see the Southern Cross. But the thing that you don't understand is that on a flat plane, you have Polaris and you have the Southern Cross, which both remain stationary and fixed, whereas stars turn around them. And that's every day of the year, no matter where you are. So that is not possible on a flat plane because, well, the dimensions just don't make it possible. It's just not dimensionally possible for a flat plane to show two axes of rotation, or I'm sorry, well, one axis of rotation, but for you would be two axes of rotation from a flat Earth perspective. In fact, you'd have to randomly pick where the center is, where the zenith, if you will, is looking straight up and seeing either Polaris or the Southern Cross. So that's an absurdity. Perspective. Perspective does not allow things to appear to go downward as you look at something receding in the distance beyond the horizon line. There's no concept of perspective that does it. So that goes out the window. Gosh. I believe that when people speak about backing up things with evidence, well, we must physically test the evidence and not speak of the concept of saying, oh, well, we need to follow the evidence. Let's discuss, as I just did, how perspective works. Let's discuss how an axis of rotation works and things of that sort. Not to mention the math and the more advanced levels of physics that should be respected. There is no such thing as a law of convergence. I just looked it up. And if you've misstated, that's your responsibility to clear that up. But there is no such thing as a law of convergence. And if I'm wrong, I'm wrong. But that won't mean that the Earth is flat, even if I was wrong. So let's not let rhetorical devices interfere with our ability to ascertain the truth. I don't know how much time I have left.
About 6 minutes.
6 minutes. Okay.
5:30, somewhere between there.
Mm-hmm. So water, to say that water is perfect, like the surface of water is perfect over 70%, how do you define perfection? The fact that you assume that from where you start to as far as you can possibly conceive, not as far as you can see, but as far as you can possibly conceive, you assume that the water follows the same path along your line of sight. And because the scale of the Earth from your point of view on Earth, standing over the Earth, or even from a high point, you presume that the dimensions of the Earth remain flat because what you can see from your perspective is dimensionally flat, but it's only dimensionally flat from your limited perspective. And I can acknowledge the challenge of looking at the argument and saying, well, on one hand, you're saying it's flat as far as it can go. And on the other hand, you have this opposition that says, well, no, it actually curves, but the scale of the curvature is such that you can't perceive it from your perspective on the surface or above what you would consider a high enough altitude before other arguments come into the conversation, arguments about whether or not even higher altitudes have been validated by accurate photography and trustworthy sources. But that's neither here nor there. So then, so back to water. So with water being the way that it is, water forms around the center of mass. Whether that center of mass is gravitationally bound or affected by static forces or is influenced by other settling objects near it is that's the distinction. Okay, so you can't assume that because you see it level with a cup or even across a lake, that it can't be forming around a center of mass. And you spoke earlier about how the ground, how the earth itself couldn't possibly cause itself to be formed around a ball when 70% of the water, 70% of the surface is water. But that surface, the earth isn't a hollow shell with 70% of that hollow shell being water. The water is a 70% of the mere surface, and within the depths of the earth are heavier metals and heavier compounds that account for the gravitational pull that debunks and refutes the notion that you have that the ground can't possibly cause the earth to form in such a manner with water 70% on the surface. And then oh yeah, no motion. Okay, so yeah, we go to scale and perspective, but I'm not talking about visual perspective. I'm talking about your limited access to the vastness of the earth in one sitting. I cannot see from here to China, and you so to say that there's no motion or no curvature is presumptuous, because first of all, you are ignoring the evidence that has been presented from the way that a ship can go over the curve, to photographs that have been taken from high above, from other forms of measurements that you have questioned arbitrarily. And I will leave my intro on that. The arbitrary rejection is an illogical and biased way to make your argument. So extraordinary claims requiring extraordinary evidence. And as I was saying while we were waiting, if you believe that the earth was flat in the first place and you saw a ship go over the horizon, that is extraordinary. Also, when you see the stars go around you, and these stars are supposed to be fixed, and you're in a dome only can allow one point that isn't like an axis of rotation for those stars to travel around, which would be either Polaris or the Southern Cross. Cannot be both. And if you try to explain one with one type of method and another with another type of method, that is an absurdity in upon itself. In addition, another extraordinary thing you would see, the sun and the moon never change their shape in the sky. So those are extraordinary evidences that respond to the extraordinary claim. So with 3 minutes left, I'm going to try to review everything I said. There is no such thing as the law of convergence. The vastness of the earth requires us to use a greater, not just visual perspective, but positional perspective to ascertain the dimensions of the earth, because those extraordinary evidences that I mentioned a moment ago require they themselves to have some kind of, for lack of a better word, logical explanation. And so as you see these extraordinary evidences present themselves, instead of trying to find an alternate explanation that violates Occam's razor and makes things sound more complicated, you would use a very consistent explanation, which is that the earth is a globe. Water is not in a perfect, there's no such thing as a perfect surface for water. The concept is that water appears flat across the vastness of the earth. But as I said earlier, and I think that is where I got cut off, you cannot see from here to China. You can't see from here to Australia. You, my friend from Australia, you cannot see the United States no matter how high you go, okay? And because of that, you cannot presume that the earth is flat, because the amount that you can see merely appears flat to you. And then you come with these other explanations for all of the extraordinary evidence that you said requires an extraordinary claim. 1 minute and a half to go. Religious beliefs do not matter. I mean, that's just a red herring. We could talk about religious beliefs all day. I don't really care, So anyone that wants to buy into the fact that I believe that the earth is round or spherical based upon those extraordinary evidences, but that's actually religion, well, you can redefine religion to mean whatever you want. Hey, we believe that electricity powers devices. That's a religious belief. Okay, extraordinary claims require extraordinary evidence if it's not religion. Okay, hey, look, I'm able to test it. I'm able to measure it. I'm able to rely on it. So that takes religion out the window. Perspective does not grant you a license to simply use the word willy-nilly. Oh, perspective does not explain why the sun and the moon go beyond the horizon and under it. And the idea of perspective would have to imply that something so far away would appear to go downward the further away that it is from you. And that doesn't come
30 seconds.
And the last thing, I think I said this already, there is no such thing as a law of convergence. I've been looking this law of convergence up for like a while. There's nothing in the laws of physics. And if you reworded it wrong, it is your responsibility to correct the wording. And I'm done.
Thank you so very much, David, for that wrap up of your open statement. We are now going to move into open conversation, but I do want to hand it over to you, Iron Horse, as the first ball, just to make sure that you would like to cover everything as we move into it. But gentlemen, the floor is indeed both of yours.
Yeah, thank you, Amy. No, thanks for the deference. Even though Amy just said I can go. Yeah, I saw a couple of comments that said that I had to do my intro all over again too, so I'm not going to, because whether or not it went through will remain to be seen in the repeat. It's neither here nor there. Unfortunately,
and yes,
David didn't.
It was all good. We got everything. But
sweet, all good. Yeah, David. Well, I don't know if you heard my first rebuttal that I did or not. That might have been lost with it as well, but he basically didn't present anything. As I said, the globe is the extraordinary claim, so it requires the extraordinary evidence. He provided nothing. He keeps talking, well, he asked several times about the law of convergence. Now, fair enough, if you Google such a thing, there probably is no such thing as a law of convergence. It's pretty much like, say, if you Google the law of common sense. You know, you can't just Google the law of common sense and expect to find that it's going to be set down by somebody, probably, from 500 BC or whatever. He's got a law written in his name, Pythagoras or somebody. The law of convergence is a simple thing that everybody sees. If you just look down a hallway, you look down a tunnel, you can get your empty toilet paper roll tube and look through that. The law of convergence says that the further away something is, the smaller everything converges towards the far distant point. And so it shouldn't have to be written as a law. It is as simple as common sense. And when it comes down to understanding how we see across the flat plane of Earth, and the law of convergence describes that everything beneath us will rise up, will appear to ramp upwards. You can see it in every single photograph ever. If the Earth was a ball, the water shouldn't be ramping up to eye level. It should be curving away, straight away. It shouldn't get any further than 3 miles at the most. But because we see it ramping up to eye level, then the law of convergence means everything ramps up to eye level and everything above us ramps down. But because we can see through the air, but we can't see through the ground, then anything that's further than that distance where the ground is ramped up to eye level will be obscured bottom first. So the law of convergence says that the sun appears to set because it gets sufficiently far enough away that the things nearer to us start to obscure it. And it applies to everything. And the best example I can give is an ordinary tall building. And any street, any city, anywhere you go, if you walk towards this building, you will see you have to look way up high to see the top of it. As you walk away, it appears to get lower and lower. Now, if a cloud gets obscured by this building, you would have to be mentally just incapable of comprehension of reality to think that the cloud itself has gotten lower than the building. And yet the glober will try and tell you that the sun has gone beneath the horizon simply because you can no longer see it. It's exactly the same process. The clouds are much higher than the building. The sun is much higher than the horizon. You just can't see it anymore. That's the law of convergence.
All right, so let me respond. What you're calling the law of convergence is merely a law of perspective, and it's just a convoluted, right? It's just a convoluted way for you to explain how things proceed into the distance to what artists call a vanishing point and what I think physicists call a convergence point. It's neither here nor there, because the fact of the matter is when you are standing and you're still between 5.5 and 6 feet tall on average, the land that you see from here to the horizon is simply the land that is below you all the way up to the horizon. If there is anything between you and that horizon that is 6 feet or higher, it's going to obscure everything from you to that horizon that is below 6 feet. So you've confused perspective with elevation. And you've presumed it because you stand 6 feet, that when you see the horizon in the distance, you're seeing a horizon that, what did you say, ramps up to your eye level. It doesn't ramp up to your eye level. The fact of the matter is you can't discern from that many miles away whether or not that horizon line is 6 feet high at your eye level or 6 feet lower. It's too far away. 6 feet from your point of view, going so far away, you couldn't see it. Even with binoculars, you couldn't see it. Even with a telescope, you could probably barely see it. Even with your P900 or P1000, you can't. You cannot see a 6 foot. I'll wait. You cannot see a 6. Well, it's not. It's laughable, but you could not tell me from where you're standing what you see at the horizon line, whether it's 6 feet or not. You can't discern that and say, oh, it's at eye level or it's not at eye level. There could be something that is on the horizon line. Let me finish. There's something that on the horizon line that is 6 feet lower than where you're standing and something else that's 6 feet higher. From that distance, you can't tell. And the only thing that makes stuff level is gravity and your sense of balance. Because you have a sense of balance, when you're trying to balance yourself, you're able to discern from your own sense of balance in your ear and the fluids flowing in your ear when you're off balance. That's all that you're doing, and that's because of gravity. The other thing that you made that was a mistake is...
Shall we stick to that point before we go ahead to your next one?
I mean, we can pick whatever one we want.
Yeah, because that's why I call a convergence point. It's a point. So that 6 foot is where it's converged to a point because of your viewing height.
No,
but if you get higher than 6 foot, then that point gets a lot further. You only have to double your height to see double the distance. It absolutely
doesn't. No, it doesn't. It just if you just look a little higher, you just look a tiny bit higher from where you're standing. But if it's so far away, I wouldn't like. Let's say I'm standing here.
By looking, did I though? I said by getting higher, you can see further. I didn't say by looking.
But even if you were to get higher and you look beyond the distance, you still can't discern and say, oh, gee, that's not rising to my eye level, because the key phrase that you're using is rising to my eye level. Yeah. Rising to your eye level rising to your eye level is almost like a metaphorical concept. Nothing is rising. What's happening is when you're out of balance because
we're not saying it's actually rising. We're saying it's visually rising to the eye level.
Your eyes are simply pointing in that direction.
That's what the word horizontal means. It's horizontal to the eye.
I'm talking about rising.
Your horizon will be very near to you. You put your eyes at water level, you can't see past water level. That's your level.
Again,
as the higher you get, the further you will see. It rises to eye level, and that's exactly how it works. And for you to go and say that if you use a telescope or binoculars, you can't resolve it, of course you bloody well can. That's exactly what we've done. This is what the flat earth has proven, that if we get huge magnification of the zoom of looking towards the horizon, we can see a lot further because our eyes do have limitations. So they see beyond the point of our limitations. And if we get even higher still, we can see even further, and it still rises to eye level. So
okay, let me see.
What you're even talking about.
You keep doing it. Once the tape is played back, I'm gonna point it out in the comments. You keep confusing distance with height. You're using distance and height interchangeably in your argument.
No,
I get the height. Well, we'll play back the tape, and I'm gonna
you change the distance you can see, of course.
No, that's not. But that isn't the issue here. The issue isn't whether or not you can see further from a higher height. The issue is whether or not you can discern what you see, because it's so far away to say, oh, it's rising to my eye level because I'm 6 feet tall and I can see that far away. Oh, now I'm on a tall building.
Still do that though with magnification, with binoculars.
Yeah, I'm not saying whether or not you can actually see the little dot or see the little 6 foot man from far away. What I'm saying is you cannot discern, and I'm going to say it the fourth time, you cannot discern something being eye level from that far away. You can presume it and you can calculate it and you can measure it, which I would appreciate that. If you would say, hey, this is eye level because I calculated and I measured it, but you're not speaking on that level.
Okay,
You're speaking of a natural discernment which doesn't exist from that distance.
You're
and that is
confusing
a
the term.
flat earth debunk.
You're confusing the term eye level with the term actual level. Now,
No, I'm not.
Eye level means visual. So a visual
I'm talking
thing,
about the rising part.
Everything is visual. Okay, that's how we see it. It's visual.
So
if we use something like a theodolite or a leveling device, we can actually see our true height as it would be at that distance.
But that's not what we're talking about.
That convergence, the law of convergence, which is a part of the law of perspective, means just like when you look down a hallway, a long hallway, everything converges upwards. Everything
it's
converges
just called the law of perspective. You're elaborating too much. There's no law of convergence. There's a convergence point. Well, everything goes towards a vanishing point. But again,
diminution, so things appear to get smaller, but you also got convergence where everything appears to converge to that point of non-resolution.
No, it's not that things appear to converge. No, here what happens is, let me speak. What happens is you're confusing another thing. You have objects that are man-made that follow a line, let's say a street or a few blocks. And the lines of those objects in our society, we build 90-degree angle walls, 90-degre angle buildings, 90-degree angle windows. We built that though. That's not a natural thing. We could have built amorphous looking huts for all it mattered, but we didn't. So what happens is we're used to seeing things like that. If you were to probably talk to people from other cultures, they would probably have less of either an appreciation or a knack for catching on to that. Not that they couldn't, because it's probably even natural for us to understand it. But you're confusing perspective lines that you can see with like a sunbeam or with buildings that are been built along a industrial plan with some kind of law. And what I'm trying to get across to you is that has nothing to do with whether or not something rises or not. It only rises if you look at it. If you look down, then something will appear to rise. If you look up, it'll appear to fall. That's all that is. And so from the distance, and we're wasting a lot of time on this, but the audience knows it's pretty clear. It doesn't matter how far away something is. If you aren't looking right at it, then it's not at your eye level.
Okay, you've wasted a lot of time on that. And basically,
I don't care what at it, it's not at your eye level.
I don't care what culture people come from. If you're going to build something that is perpendicular to the ground, then you have to have a flat and level surface to build from in the first place. Now, you can build according to sort of shape.
I'm not disputing that.
If you want to build them like a dome or whatever sort of shape. Well, you are disputing that because you're saying
I'm not.
The ground
and guys,
I'm saying that has nothing to do with your concept of seeing something rise to your eye level.
Guys,
being quiet while you spoke.
You interrupted me a few times. Go ahead.
Guys, I enjoy the enthusiasm, but I'm going to pull you apart. And it sounds like, Iron, you were in the middle of something. And so I'm going to let you finish your statement and we'll go back and forth again.
Yeah, thank you, Amy. Because basically everything is built according to the flat and level surface that it's built upon in the first place. If you're trying to build something across a curved earth, well, then that perpendicular will change over a period of time. It doesn't change. It's the same. Plumb is plumb, no matter how far you go. And this has been measured. The greatest argument that I hear from a lot of globers is things like the Verrazano, any sort of suspension bridge where they say that the main columns lean away from each other and that proves curvature of the earth. And yet you can go to that exact same city and find buildings even further apart than those, and using laser measurements find that those same buildings are exactly perpendicular to one another. So the reason suspension bridges are built that way is simply because it's a structural engineering thing to have very tall things with all the weight pushed down on them in the center, to have them slightly leaning away. They're the only bridges in the world that are built that way. So everything is built perpendicular, plumb to the level surface of the earth. So all that other nonsense that you ended on with, it's meaningless. It's got no basis in reality.
Right. May I respond? Okay, so first of all, you've confused local level surface with the universal, the entire Earth's level surface. So it is obvious that buildings are built according to a level flat surface, but it's a local level flat surface. The building that is built in New York City does not need dimensions and calculations from Australia to know its level position. Okay, you're presuming that they must be parallel to each other, and you didn't even use the word parallel, so I'm going to use it. So there's your next mistake. The Earth is, I don't know what the calculations are, but if it's 24,000 miles and all of that, I'm going to assume that each degree is, I don't know, about what, 60 miles or something?
Miles.
Something, yeah, 60 to 70 miles. Now, with that being the case, a building isn't a mile wide. A building is maybe 30, 40, 50, 100 feet. I don't care. Those dimensions are not requiring your concept of curvature to be calculated to such a degree that you're looking at the building's warp. And then on your last point, when you say, well, hey, they did a laser calculation between this building and that building. Well, let me tell you what's going to happen. You find that example, and then we're going to measure the next building and the next building and the next building. And we're going to measure all the buildings around those buildings. And the further out you measure, you're going to see all of the laser distances diverge. They're not going to be parallel. And that's your presumption. You presume parallel when there was none.
Okay, well, that's your claim.
So,
but that's not a claim.
You made the claim about the laser. I want to see this laser. I want to see this experience. I'm looking it up. I can't find nothing about a laser that says, hey, all these buildings are level. You might find one. You might find one or two. You might find one or two that are a couple miles apart. The human imperfections in building and the effects of wind and building settling, the Leaning Tower of Pisa. Yeah, you're probably out of the thousands upon thousands of buildings throughout the universe. I mean, throughout the world. Yeah, you're gonna probably find a couple that are near each other that just happen to whatever. Okay, but that's not even. That doesn't even say anything because you're still left with a gaping problem. You see the boat go over the horizon. You see the stars with the two axes of rotation. Okay, you can't sit up here and wave that away. And I didn't even get to the good stuff, which if I have time, you're toast.
Right, yeah, well, I'll rebut two of those. Then you said boats over the horizon. And as I've already suggested, look, we can use a powerful modern day zoom, something that the ancient Greeks weren't privy to, and we can see these boats and nowhere near the horizon. The horizon does extend into infinity, and we can see boats way, 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 way further than the naked eye can ever possibly.
When is this ever going to happen?
Because the globe curvature is based on the limitations of our ability to see, where we assume that's where the curve begins.
No, it's not.
Your other one, hang on.
No, it's not.
Yeah, you keep coming up to me here.
You're just making claims and there's nothing to back them up. Like, hey, we measured it to X next miles.
Plenty of proof that we can see way, way further than the naked eye can possibly see. These are the things that they didn't have back in the day. We have that technology now. I should have kept a note to see what your other one was because it's already gone out of my head.
But the thing is, the boat goes over the horizon within our visual capability to see it. So that there's no relationship between how far can we see with or without a tool versus, oh, look, the boat's going over the horizon. Because here's the thing, if you're standing 6 feet over the sea level, you're going to see that boat go over the horizon with binoculars or telescope after a few miles. But if you're standing on top of the Burj Khalifa, it's going to take probably a few thousand miles, I don't know, a few hundred miles at least to see the boat go over the horizon.
They say, you obviously don't even know your own model. You don't know what the limits of curvature are. Like, I'm glad
I don't know the precise calculation of numbers because it's not material to the conversation.
Yeah, I'm going to break you guys apart again.
Thanks. So you brought up the Burj Khalifa. Now, that's a great example because the Burj Khalifa at this current point of time is pretty much considered the world's tallest building. Now, as we understand height, if you stand beneath a tall building, it looks extremely high. Now, this one is 1/2 of a mile high. Now, if we follow the globe curvature calculations, now these aren't my calculations. These are yours. These belong to everybody who believes we live on a spinning space ball hurtling through space. Is that our ball is slightly less than 25,000 miles in circumference, which means that there has to be a curvature scale that over a period of 90 miles has 1 mile of drop. So that means you've got 2 Burj Khalifas, one stacked on top of the other, of drop at just 90 miles. And yet, if you got on the Burj Khalifa, you can see way further than 90 miles. If you get up in an aeroplane, you can see way more than 90 miles. And yet that should all be hidden behind a curvature drop of over 1 mile. And that drop does not exist. It's never been seen, but that is your belief. And so your belief is obviously a fantasy, and therefore the globe is debunked.
All right, see, that's where I got it.
Because there is not a mile of drop to be seen within 90 miles of any vista.
Okay, you're finish that statement, and then David, it's all yours.
Yeah. There is no mile of drop to be seen within any 90-mile vista of anywhere we can see. We can see way more than 90 miles anywhere, and 1 mile of drop is fucking huge.
Thank you, Iron. And then David, the floor is all yours.
All right. So look. You haven't determined what you can and cannot see from the Burj Khalifa. I have not determined that. Okay. I don't need to know the exact calculations of the curvature calculator in order to know how far I should or shouldn't see under certain circumstances. Because here's the thing. At some point, you know that you're seeing that boat go over that horizon. If you were to say to me, well, hey, I saw the boat go over the horizon, but I saw it go over the horizon at 2 miles up. The earth is flat. No, that sounds absurd. That just means that there's some other factors and a lack of experience to precisely determine where the curvature is supposed to obscure your view. But that does not mean that there is no curvature. That just sounds absurd. Now, I'm going to actually go to a particular thing here that fascinates me. Is this your flat earth? Is this it? Do I have an understanding of how the flat earth is supposed to look? Or is it a different
more or less like a presentation of how it might be mapped out? Yes.
Why it might be mapped out. Okay, so now I want you to explain something to me. Why is it? Oh, I'm sorry. Is the sun local or is the sun millions of miles away?
Well, it depends by what you mean by local. I mean, do you go to your local store? Do you go to your local store 70 miles away? Do you call that local? We don't have a lot of
time left. Just give me a range of distance. We're going to
okay, so if I'm going to go down to my local store to pick up some bread and milk, would I travel 70 miles and call that local?
Can we not waste our time with trying to argue about what local means? And you tell me 200 miles, 2,000 miles, 20,000 miles, 200,000 miles. How far away is the sun? It can't be greater than how many miles away?
Well, if I'm telling you that the sun that we see,
just give me a number,
is local, but
just give me a number.
We only see it 70 miles high, and we see it through our atmosphere, which is only 12 to 14 miles high. Now, but it doesn't mean that's where it is. It just means that's where.
But you know that it's not 1,000 miles away. You, if I were to say, hey, the sun is 1,000 miles away, you say, no way, no way, no how.
As far as I'm concerned, the sun might be 3,000 to 4,000 miles away, but that's
or 3 to 4 million miles away.
See it.
Okay, so but is the sun 3 to 4 million miles away?
No, it's about 3.
Okay, great. 3 to 4,000 miles away. Now, here you go, buddy.
That's where you're going to see it, does it? You know, you're trying to perspective. You're trying to use a top perspective to explain how we see something from the bottom looking up at it. It's not going to work. Are you going to use a person sitting on your little map looking up at the sun to show how perspective works, or are you going to try and do something to try and straw man them?
Well, okay. Filibustering. So here's what I'm doing.
Make your point.
Here's your sun. Right now, I want you to check this out. It's going to be hard to see.
Doesn't look like my sun.
Let's say right here, New York City. All right, that sun is some thousands of miles away, and it's this big in the sky. It's what, a third of a degree. I'm sorry, a third of a degree, I think. Whatever it is, right? And that sun, that's a great argument. Hold on. That sun goes from one part of this earth to another on your flat earth, and it stays the same size in the sky every single time. The moon, the same thing. It's 1/3 of a degree, no matter how close or far away it is. is 4,000 miles away over here. Your flat Earth is supposed to have a dimension of about what, 36,000 miles. So if I'm in Australia and it's sunrise for me, and someone in Japan sees the sunrise at the same time, and they see that sun is the same size, something ain't flat. You can't have a flat Earth in that kind of circumstance with a local sun either. And then lastly, when you see the sunset, it was just the solstice. The solstice had just passed. So you're looking east for the sunrise, and you're looking west for the sunset. You're in Australia, and I'm in the United States. How in the heck can you look directly east during sunrise and directly west during sunset, and I can do the same thing, and that sun is supposed to be local? Not humanly possible, not physically possible. Not even talking about math or science. We're just talking about perspective. I'm done.
Okay, well, I appreciate you trying to make an argument. It's you obviously proved that you're quite ignorant about the matter of things, because the equinox is actually not the solstice, but you call it a solstice.
Mixed up. The words get mixed up.
Well, it's not just a mix-up of words. These are very important factors. The solstice is the turning point of the sun getting above us and the sun getting to its lowest point. That's why solstice comes from the Latin word that means turning point.
Concepts, not words. But go ahead.
Equinox comes from the word equal nox, which is night, and equal lux, which is light. So it means equal day and night. Well, an equinox is just what happened. And when it comes to words. Well, no, but I haven't finished, mate. When it comes to then directions, what you think you're seeing at, we are seeing through a very, very tiny. If you have a look at your paper map there, and now you draw a little dot where you live, draw a tiny little dot, and you draw a circle on that dot where you are. You don't have to show me your map. I know.
I want the audience to see it.
Find exactly where you are. Draw a dot there, and then draw a circle around that dot that shows you your local horizon to your local horizon. And then that's your field of perspective that you see every single day from sunrise to sunset. Then you think that you can see, half the world at a time every single day? No, you're only seeing your tiny, tiny little dot of perspective, which proves that the way we see the sun from sunrise to sunset is our local perspective. We're not seeing half the world at a time. Yeah, can you please mute yourself or something? That noise is annoying.
Oh, you hear noise? Okay, yeah, I'll mute myself. No problem. There.
Thank you. That'd be great. The point that we see from sunrise to sunset is always going to be local. It's basically 3 or 4 miles from one side, 3 or 4 miles to the other, and it is not even a visible speck. It's not even a pixel that you could put on that image to show. And yet you think that the sun is showing over the entire 50% of the earth that you can see through that visual range. What was the other one that you said? Geez. You keep distracting me.
Why don't you let me get a chance to get a word in now? Let's focus on that sun.
Antics, mate. No.
I'm going to do my antics. Okay, look. Let's get to this. So you just said so yourself, 3 to 4 hours, right? So here's where you make your mistake. That's why I use this map.
No, that's kilometers or miles.
I'm sorry, what? You said 3 to 4 minutes?
You said hours. I said miles or kilometers.
Miles.
That's to the horizon to horizon.
Right.
Around
so watch this.
Local perspective. Right.
So check this out. So I'm here in New York City or wherever, right? And I see the sunset. Okay. When the sun sets at 9 o'clock, the sun is way over here next to Australia, right? At sunset, it's over Australia on your flat. It's over Australia on your flat Earth map. It ain't high noon in Australia. If the sun's right here, then it's high noon in Australia. If it's 12 o'clock for you, my friend, if it's 12 o'clock for you, what time is it right now over there?
It's exactly 12 o'clock.
Okay, it is 2,200 hours over here. Okay, so
cool.
Depending on what part of Australia you're in, right? So here's my problem. Here's your problem, rather. My problem. Let me put this thing upside down.
It's your problem because you can't understand perspective.
Right. No. It's not about perspective because your point of view is no.
Because we are on the ground.
Let me finish.
We're on the ground. We're looking up at the sun.
I tried to get my 2 minutes in. Let me finish. Come on, bro.
And now, guys, no one can hear you. So
right, no one can hear it. So come on, I'm gonna finish.
So David, finish your point, and then we'll hand it right back over to Iron.
All right. So your perspective is no worse than mine. Your perspective has equal weight to mine. So just because I can see it, sun setting, I see a sunset. And here's the thing, the sun sets from any person's perspective, from a flat earth point of view, maybe a dozen miles from the horizon. The horizon is right there. And you're seeing the sunset. So you can't say that the sun is, what, 1,000 miles away. And then here's the killer. Let me show you this last one. Here. The sun sets at the same exact time. The sun rises at the same exact time in New York as it does way down here in Chile. Okay? So you pick one of them little cities in Chile and you see the sun rising and setting at the same time. I'm not looking halfway between here and Chile for a sunset. I'm looking due east. I'm looking, check it out, bro. I'm looking this way. Well, I'm looking, come on. I'm looking way out here. Way out here. I'm not looking. Oh, come on. I'm not looking way down here. But the Chile person, he's looking this way. He's not looking way up here. He's not looking way up there. So you have a perspective contradiction in your point of view. I'm done. I apologize. Thank you.
Wow. My mind is actually absolutely blown by that. That's just like, oh, how could I have not have seen that before? Like, geez, yeah, we're looking across the flat surface to see the sunrise. No, we look up to see the celestials. We see the sun advancing towards us, and that makes it appear to rise up. And while we may be looking in the same direction, that same direction locally, if you plotted that out on the AE map, as we have done, that's exactly where we see your east is different from the person in Chile, or you might call it Chile, but we say in Australia, Chile. He's looking to a completely different east, but he's still looking up and seeing the sun, basically following the same path, because that's how perspective works when you're looking from the down up to see things happening. That's exactly how we're seeing the sun. Anything that's high above us, it is a matter of perspective. So directions are irrelevant. They're completely localized. So here in Australia, if we look, say, south of east, that's a completely different south of east. If you drew it as a straight line to the person in Chile, he's looking at a complete, from our perspective, it would actually be looking slightly northwards. But from their perspective, it is south of east. All of these things are easily explained. You know, if you've got a bunch of people in a big circle and that you said, okay, everybody, your left is west and your right is east, everybody has a different east and west from every person looking at each other, and everybody looking towards the center, they're looking towards the north, which is completely different. They're still looking at the same thing, so we still call it north, but their personal perspective of north is completely different. And if they look outwards, southwards, their south is completely different from everybody else's. So directions are just as subjective as everything else. And if you can't understand it on a big scale of the size of the earth, then you're going to completely be believing that we're seeing the same thing when we're actually looking at something completely different.
Okay, so look at what you just said. You contradicted yourself. You said everyone's looking at a different east, right? But there's a problem. The sun can only be in one of those easts at a time. The fact is, when you say, hey, it's all a matter of perspective, everyone's perspective is different. The sun can only be in one spot. It can only be in one position. So if hold on, you done had all that floor time. So if the sun is somewhere in between, then everyone, I would be looking south. I would be looking southeast, and the people in Chile would be looking northeast during the equinox. Hey, you know, I'm going to give you a free point. I should have said equinox and not solstice. But that's not what happens. The people aren't looking in different perspectives. They're looking in the same direction. The person
they're not. I just told you that.
They are. Yes, they are.
Personal version.
Let me finish my floor, man. You had your time. I got chastised, rightfully so, for interrupting.
Yeah, but you're trying to negate something I've already just explained.
No, let me finish.
You can't tell me
here's the thing.
that your version is right when I've just told you how wrong you are.
And with that, David, we're going to let you finish your statement, and then we're going to throw the ball right back over to Iron.
You did not tell me how wrong I was. You simply arbitrarily decided that, hey, he's looking east, but his east is not really due east. But my east is due east. And what I'm trying to get across to you is that the people are looking at the sun facing their due east, both of them at the same time. Even though on a sphere, not on a flat plane, two lines will converge, since you're a flat earther, that does not apply to you. So you can't use that argument. So they're parallel to each other. The two people that are looking due east are parallel to each other on the flat earth. I'm looking at it right here.
Well, as I just said, if you've got a range of concentric circles coming out from the North Pole, as we see it, and they still consider the east to be the same, even though for each person from a different longitude line is looking at a different east, because it's a circle. The sun is moving in the arc, in the circle around us. So what I see as east and a person over in South America sees as east is a completely different direction. We just call it the same because it's on the same circle. But it doesn't mean
tangent lines, bro.
Exact direction.
No, the tangent line at their position is the difference. You're ignoring a certain concept. When you're at a point on a circle or on the
I'm ignoring a certain concept.
I am explaining what you're ignoring with clarity. You have what's called a tangent line. Anytime there's a straight line that goes across a circle or a spot on a circle or on a sphere, that is a tangent line. Now, it's hard to call this a tangent line. I think this is called something like a chord or whatever. It doesn't matter. Just like I got the word solstice and whatnot confused. But what I'm trying to get across to you is that when the person in one part of the world is looking due east, and I put this line too high up, so forget that line. Let's just use this line. Forget that line.
What about the tilt of your Earth? Isn't your Earth tilted at like 23.4 degrees? How can it be the same? If
the two people that are on the Earth are tilted in the same 23 degrees. I'm tilted at 23 degrees along with the other person tilted, and that's only relative to being parallel with the Earth's rotation to the sun. I can still look at the sun and still see it over there.
But no. But your ball has got like 8,000 miles of fucking diameter.
The sun is 93 million miles away.
It's like going over a huge hump, isn't it?
Like, it's not like going over a huge hump. No, that's not how it is.
Is in a completely different part, you know. We've got
like because you have latitude and longitude, and you're ignoring the fact that the people are looking in the same direction people are looking in the same direction to an object that is very far away, and there is no hump.
You have to assume then the curvature of the Earth. There is a massive hump. It's a massive hump.
Yeah, that's called night. When it's nighttime, that's the hump.
No, the hump.
That's your hump.
A circle is all hump everywhere. It's hump.
Yes, but the hump isn't always around you, or else you would be inside of a bowl. Yeah, so look at it like a bowl, but that's not how we're talking.
The side of the hump compared to then at 90 degrees, the midday side compared to the other 180 degrees. If that's tilted,
it's about morning, noon, and night.
You've got a completely different line of sight towards the sun because of this freaking hump and this.
That's called night. The third time. You're wasting your time. That's night. I get what you're saying, but that doesn't apply when you have.
I'm just talking about day. I'm not even talking about the night.
So when you're talking about day,
sunset.
Listen, when you talk about day, you're confusing people looking at each other from far away with the people looking at a far away sun. If I'm trying to look at the person from Chile, yeah, there's a hump of Earth in between me and Chile, but that hump does not mean that the distance far away cannot be seen for that.
Yeah, but you're talking about a longitude line. I'm also talking about on the left.
That's what I'm saying, just like solstice and equinox. It's a word, but I'm describing to you what happens. You can take the word and say it's a longitude. I can say latitude and longitude. It don't matter. What matters is that listen.
You don't understand what I'm talking about here. Okay, you and that
word, but you're ignoring the concept.
Same longitude line. So you're going to see the sunrise at the same time, and you're going to be looking east, and you're going to see it at the same time. But that Earth has still got the 23.4 degree tilt for people 6,000 miles away. Well, that tilt changes the view of the hump.
No, it doesn't. I'm not looking at a hump. I'm looking at a sun in the sky.
In direction at midday. The sun.
No, it's not. See, here's
You
the
don't
thing. At some
understand.
point, okay, let me speak. At some point, the sun will be visible high in the sky. At some point. So you keep talking about this hump, this
Midday.
hump, this hump. At some point, listen, at some point, the sun is visible to the people from Chile to the United States. It's visible high in the sky. So somewhere between high in the sky and your hump is sunrise and sunset. Somewhere. You pick the time, you pick the distance
Okay,
or the
I'm
hump.
picking
I
the
don't care.
time, and the time is the equinox. The time is the equinox, okay?
No, that is
You
a
both say you
day
see the
over a
sun
period of a
rise
month and a
in the
year,
east.
bro.
You see
That
the
is just a
sun
mere
rise.
day. It could have been
Just a second,
June
mate.
30th. It could have been May 15th.
Guys,
It don't matter.
Exactly.
Just a second.
I'm in that we're gonna break you both a point. In that Iron, the ball is yours, and then when you're done, back to David.
Right, yeah. So we've got this ball. It's got this circumference. And so from one side to the other, from North Pole to South Pole, we've got about 12,000 mile curve. So the equator is 6,000 miles either side. So you're talking about New York and Chile, and they're both looking due east to see the sun come up. Now at midday, that curve means that the shadow cast from the sun because of the curve should be showing completely different things. And yet on your model, you claim that the shadows are still directly overhead, casting no shadow at midday on that particular day. It doesn't work because of the curve. It's an 8,000 mile diameter. So you've got 6,000 miles to the middle, 6,000 to the other side. Let's say we're both at 3,000 miles away from it. That angle of shadows should be completely different, but we still call it the equinox because we've got equal day and night. It doesn't work on a ball. It can work on the flat surface because the sun is at the exact center of its personal rotation going around above and below us, and that's why we have an equinox on a flat and stationary Earth. It does not work on a ball, but obviously you don't really don't
waste our time. Let's just get right to it.
What I'm talking about here.
Come on, man. Let's just get right to it. Okay, so you confuse shadows at sunrise with shadows at midday. So there's your first mistake. Let me finish.
I'm not talking about shadows. It's not shadows. Directions.
Huh?
The direction is you're saying that on the equinox.
I'm going to tell you what I'm going to say. Let me say what I'm going to say.
Coming up. It's the midday shadow.
Filibuster.
The shadow at sunrise. Go ahead.
All right. So anyway, the shadows on sunrise during equinox are going to be parallel. Dude,
Well,
I didn't even finish like my first statement.
Gonna pull you guys apart again, and so David, I'm gonna give the ball to you, and then it's gonna go right back to Iron.
You have been so fair. I greatly appreciate it. Thank you.
Oh,
So, yeah. So anyway, the shadows at sunrise, will they be parallel? I don't know. I believe they will be, but that doesn't matter because come midday, the shadows are not parallel. What will happen is you'll see the shadows. If you were to look at both positions, the shadows would slightly diverge from each other. Not by much, but they would slightly diverge from each other. Well, actually, no, they would diverge from each other quite a bit at midday. But, well, that's the point. And so when you have this argument about shadows and their positions, you're still ignoring something. I see directly east, the same parallel direction that someone 6,000 miles away can see. And there's another problem. Your sun and moon do not change size in the sky. They don't appear larger and smaller depending on how close you presume that they are or how far away they are. And that is far worse. Okay? I could go on. If you say that the moon is flat, then it should. I'm not done. I'm not done. I get my 3 minutes, man.
Actually,
go ahead.
Yeah, the first argument was we're talking about the equinox and the sun appearing to rise due east. And all you could talk about was shadows at sunrise. You don't have shadows at sunrise. Like we're talking about directional things at the equinox where the sun appears to rise personally from each perspective. And that's what happens is everything to do with looking at the sun is a personal perspective thing. And that's why when it's the sun's height to everybody across our whole wide world, we'll see it rising at the same direction on that particular day and setting at the same time on that particular day. And unless you had this curvature at that same time, then that's why you don't see a shadow at midday on the equinoxes. So
you're talking about shadows all of a sudden.
But then you're the one that's mentioned shadows.
That's because you mentioned them first. I'm petty.
Only in the midday time, because at the midday time is when you can tell where the shadow should be. And if it's directly overhead, you will have no shadow. And that's what happens.
And the only place it can be directly overhead with no shadow is between the Tropic of Cancer and the Tropic of Capricorn near the equator. That's the only way you can never see a shadow when it's directly overhead. And that depends on which day of the year you're talking about. So that's out the window.
We're talking about an equinox, yes.
Yeah, but Chile and United States are not in between the tropics. So that doesn't apply here. I'm trying to get across to you is that you said personal perspective. Now, why can't I see you the same size that I can see my best friend? My best friend, he's right there. Why can't you see him with your personal perspective? The sun is this big in the sky, no matter where you are on Earth. And it's the same size for everyone on Earth at all times. The same thing with the moon. The only divergence, and someone in the chat, yes, I get it. There's a 2% variation depending on where you are on Earth. Whatever. Okay? The fact of the matter is you're not looking at the moon or the sun in the sky and going, wow, it's a lot closer now. How do you know? Because the Earth is flat and it's only a couple thousand miles away. I mean, what happened to Pythagorean theorem? What happened to your law of perspective, your law of convergence? Your law of convergence, you have contradicted yourself by bringing up this personal perspective. Your personal perspective destroys your concept of the law of convergence.
Okay, well, no, it doesn't for a start, because as I've already explained to you, that our personal perspective is through a very, very tiny field of view. As I said, if you could draw a dot on your map to see how far your horizon is from one side to the other, it's very, very tiny. If you drew a circle around it and you zoomed out, it won't be very long before that circle itself has disappeared. It doesn't even exist as a tiny pixel.
But once the moon does?
I'm talking okay. So as you zoom out, you see virtually your field of view is very, very tiny. So to say that then the sun and moon should appear to change in angular size, I mean, there's no reason whatsoever why they should, considering that both of them are projections that we see through the atmosphere. And our atmosphere itself is actually quite near, and we can only see, well, if I look out here, I've got a really good long vista. I can see maybe 5 kilometers.
Why doesn't it make it bigger? Why doesn't it make it bigger? Why does it see if it were atmospheric, whatever you just said, just whatever it is, I don't care. Watch this.
Well, because the atmosphere
itself, doesn't it change? I should see it double. I should see it triple the size sometimes.
Height. The atmosphere is a constant height. So whatever apparition that we are seeing through the atmosphere is going to remain constant. If you can see a really, really, really long, far distance away, you will see the sun or the moon appear to get smaller, but we just can't see that far. It's just not possible. Wait.
Hold up. Here's your moon and sun. So at some point, the sun, let's just say we're in Africa. No. Your moon or sun is somewhere over Africa, right? Right? And then I'm way over here, and you're trying to tell me, oh, it doesn't change in size. Well, wait a minute. Isn't there another flat Earth thing about the sun and the moon get so far away that they only appear to go under the Earth? They only appear to go down into the perspective and disappear. So at some point, the sun and the moon, from let's say sunrise to sunset. So let's say for you, sunrise is at 9 a.m. and sunset is at 8 p.m., whatever. You've got 14 hours, 13 hours, 12 hours of this sun going across the sky. And 12 hours is literally for you, for anyone. It's from one side of this earth to the other. Okay? And you're trying to tell me as this sun is going around, it doesn't change shape. It doesn't, I can't do the circle right. It doesn't change shape. It doesn't change size. But then all of a sudden, it gets to sunset and it just shrinks within a course of like 45 minutes. And then all of a sudden, so basically you're saying, hey, there's personal perspective, everybody. personal perspective, your sun and my sun, we're all the same sun. And that's how it is. But come sunrise and sunset, law of convergence. Law of convergence. No.
Well, you've actually presented
you can't even.
strong argument. You've actually presented a very strong argument there for why we actually might have a domed atmosphere above it. Because if it was domed, then that's exactly how we would see it. That is why.
No, it's not. That's not. Dome doesn't do that.
When we go to a planetarium, that's exactly why they project everything onto a domed roof, because that gives us a realistic presentation of how it looks. And so if we've got this dome above us, then that's exactly how we would be looking up and seeing it from every perspective. And everybody gets their own personal perspective from far beneath on the flat earth looking up at it. You've got
even in the planetarium. Okay, go ahead. I heard a pause. My mistake. Even in the planetarium, if you're on one side of that planetarium, you look at the little model of the Earth. Model of the moon. It looks like this. If you look from another perspective, it looks like this, like an oval shape. And if it's behind you, you can't see it. And that's another problem that you have with this whole personal perspective stuff. Yeah, it is. A personal perspective. I'm sitting up here. Watch this. I'm here. Let's say I'm living in Cairo.
Guys, I'm gonna let David. I'm gonna let you make your that point.
Final point.
We have about 2 or 3 minutes before we go into the Q&A. I do want to remind all of our audience, thank you for listening, and keep on sending those questions in at Amy Newman for the Q&A that's about to happen. But David, it looked like you were about to make a final point about something, and then Iron, I want to hand it right back over to you guys. The floor is still yours.
I hope I made you a lot of money today with those super chats. Now, you're in Cairo, and the moon is like, let's say, on the Tropic of Capricorn. I forget which one is on the south. So you're north of the moon, and the moon on your flat Earth is at the Tropic of Capricorn, right? So if I'm in Cairo and I look up at the moon, I'm going to see this side of the moon. But the people in, I don't know, Mozambique or in Angola, they see this side of the moon. Oh, but that doesn't happen in reality. Personal perspective?
Yeah, you've just proven that you've got absolutely no idea how perspective works, from being on the surface of something down low, looking up at things that look down upon us. So when we're looking up at the moon, we're looking up at the bottom side of it from anywhere on Earth, and therefore we're going to see the exact same bottom side that anywhere else on Earth would see. Yeah, you still think we're living in outer space or something, and that everything is in this space world type of thing. Oh, God, what a moron. I can't believe that this guy presented himself as a serious debater.
The moon, even if it's from high above, you have a perspective that distorts its image. You cannot claim that it looks the same for everyone from all over the Earth when the moon is right here on one side of the Earth and you're way over on the other side of the Earth. You're seeing the same face.
We're not looking down from above, are we? We're looking down. We're looking from down, looking up, and that's where our perspective.
Down and up are relative. I can be, your down is my up. It doesn't matter. I'm still looking at an object from a distance.
Shut up. You got no idea. When you're looking up at something, it's going to be a completely different view from somebody from the other side of a football field looking up at the same thing. If something is close, we're all looking up. You just,
the object looks the same. You can't which direction I'm looking at it. If I look at it from below, it's the same object.
The reality of the flat Earth, and you can't even do that properly.
Well, the object is the same no matter which direction I look at it from.
I'm going to thank both of our interlocutors for that lively back and forth. I enjoyed it. But with that, I am going to let each of our interlocutors have a moment to say what they got going on in the interwebs, and most importantly, what their final thoughts are on the subject. I see Iron Horse is up for just a second, so I'm going to actually defer to you, David, for your closing statement. The floor is yours before we move into the Q&A.
Okay, well, extraordinary claims require extraordinary evidence, and hey, we all got it. But if you don't appreciate that extraordinary evidence, we take it for granted because, you know, we're so advanced as a society, and that's all fine and good. But I know myself, when I saw the ship go over the horizon, I was fascinated. And the other thing that fascinates me is when I use a telescope and I can see Saturn, I can see Saturn's rings, I can see Jupiter, I can see Jupiter's moons, and I can see Jupiter's, the bands of Jupiter. So that's extraordinary, okay? So if we cannot respect that, then we're not being honest when we have our conversation. And then as far as this other stuff goes about perspective, perspective is not some word you can just throw out like magic, okay? Perspective says consistent. And wherever your eyes are looking is your vanishing point. Wherever wherever you're looking at is your level, okay? Gravity is what makes you feel it. As far as the horizon goes, you're balanced so that when you are feeling balanced, it's, you know, on the same plane as the horizon, and that's because of gravity. And I don't need to go on.
Woo-hoo. Thank you so very much, David, for that closing statement. Looks like Iron. Thank you for joining us both, interlocutors. But if you would like, what do you got going on in the interwebs? And more importantly, what are your final thoughts on the topic?
Yes, well, obviously, we've got another example here of somebody who's just a faithful believer in a globe Earth. They got no evidence for it whatsoever. At the very most, they tried to debunk flat Earth observations. He doesn't understand his own model. He doesn't understand perspective. He doesn't understand how we would see things from our personal point of view. It's very typical of every single globe defender I've ever come across, is that they think that they found some sort of low-hanging fruit when they come across and say, oh, we'll attack this flat earther and make ourselves look good. He's just turned around and made himself look like yet another complete and utter fool on the internet, publicly for all to see. The flat earth truth is never going to go away. It is here to stay. This is something, it's huge, it's profound, and it means a lot to us because we know that this earth actually is a seriously, it's here for a purpose. We're all here for a purpose, and anybody who wants to try and believe that we're on a spinning ball and insignificant in outer space, means nothing, oh, the sun's going to blow up, the world's going to end, all this sort of shit. These are all just fear-based projections of people. But when you come to your senses, when you understand reality, you lose all the fear. And flat earth reality is basically, it is the savior of the world.
Thank you so very much, Iron. I do want to remind everyone out there that both of their links are in the description below. I also want to send love and all the appreciation out there for everyone liking and subscribing. However, we are moving into the Q&A section. In fact, a $2 super chat coming in from Deej. Iron Horse versus Iron Man. Looks like you got a fan out there.
Oh, Iron Man, yeah. Yeah, I guess so. Yeah, I get that a lot. Thank you.
Andres for 50 from, I think that's South Korean. Question for Iron Horse. Does the sun set slightly north or slightly south of due west this time of the year?
The sun doesn't really do either. All direction is apparent direction. As I keep trying to explain, there is no east, there is no west, there is no north, there is no south.
Okay, where apparently is it setting?
On a longitudinal line, for example, yes, we can look towards north, and that is the fixed center of our Earth. But everything else is subjective. And so where we see the sun is always going to be in an apparent place. And so it might apparently appear to be set south to us from west at this time of year, now that we're coming towards our summer. but it doesn't mean that's where it actually is. It's just where it appears to us from our very, very tiny point of view.
All right. Am I allowed to say anything when the super chat is asked of someone else?
So you are absolutely allowed to respond. However,
All right.
because it was his directed at him, he does get a
Yep.
final statement afterwards.
All right, cool. So, you know, all this stuff about truth, and then it gets eliminated when you say, oh, it's all subjective. So you get to be subjective and absolute at your convenience. That is not objective, and that is not evidence-based. That is simply arbitrary, and that does not get you a valid argument.
And then Iron, if you would like to have a final few seconds.
Yeah, thanks. That's his point of view, but I will stand behind my opinion that everything is subjective. I've recently uploaded a video a few weeks back where I talk about the apparent position of the sun, and the sun does not have a position. Everything is apparent, because if you walked across a beach, for example, as the sun is setting, you will see the sunlight reflecting across the water towards you. And as you keep on walking, it will keep on appearing to reflect towards you. So that means if there's a million different people on this beach, they will see a million different reflections of water, of the sun across the water to them. And which one is real? Every single one of them.
None of them, the reflections. That is absurd.
So the problem is then reality is subjective, and it depends upon each and every individual viewer, and every single individual viewer's point of perspective is just as real as everybody else's. But they're all
no
different.
one is saying that the sun is in the water. No one is saying that the sun is in the water.
Reflection of sunlight across the water. The sunlight reflecting across the water is real to them.
And
because
right
that's how
back-
No one is the. No, let's stop there.
No, it's good. Sending love to both of you guys. And all of the people that are sending us love and support, super chat and chat. $2 super chat from Dawkinator. It was the Glober T-jump that fled from Iron Horse. Spicy. I will say it did seem David was super excited to be in the debate, and T-jump was kind of deferring to his friend here. But I actually think that there was a lot of excitement, globe and flat earth, and so send in love. $2 Dawkinator. The globe religion of David is being exposed. Oh my.
Gosh, you use observation and measurements and tried and true methods to verify information, and that's a religion. So, hey, what can you do? Hey, I worship truth. Thank you.
Do you have any actually observed measurements and observations that you can talk about, or are you just going to talk about and assume you have them, but present absolutely nothing to say that you do?
You mean, well, first of all, if you want to talk about the vastness of Earth, absolutely not. Not in this conversation. I'd have to take the camera with me outside, which is absurd.
So you're just talking about assumption.
No, I'm not talking about assumptions. Okay. Let me ask you something. Why do I see with a telescope Saturn's rings when the stars on a flat Earth model are supposed to be just points of light? Why am I seeing defined shapes of Jupiter and planets orbiting around it when it's supposed to be just? Why does Venus look like a teeny tiny moon going through waxing and waning phases if the planets are just moving stars and not actual objects?
Were you reading that? I mean, obviously.
No, I used my own telescope and I saw.
When we're talking about the Earth, when we're talking about the Earth, we're talking about the Earth. We're not talking about the things we can see through a telescope looking up at the sky.
Yeah, but the thing about it. Oh, I'm sorry.
No. I'll let you finish whatever you're saying. Interrupting to let you say, I'll let you finish, but then David will have the final word, and then we're moving on to the next question.
Yeah, he's just talking about complete irrelevancies that have nothing to do with the Earth itself. They're just talking about things that we can look up and see through telescope. When we're talking about the Earth, show me evidence, curvature, motion, and we'll go from there.
Okay, so you're in a place of Earth where you see a different area of stars going around an axis of rotation called the Southern Cross. And I am in an area of the Earth where I can see some of the same stars that you can see. And in fact, over time at night, we can both compare our measurements of time and positions of those stars. That lets us know what kind of surface we're on. That is evidence. I cannot sit up here and say, I'm on a cubed Earth, or I'm on a triangular shaped Earth, or I'm on a flat Earth, when the way that the stars move across the sky follows a gradual pattern that shows that we have to be on a spherical Earth.
You have to do it. You got a few seconds, 10 seconds, then he has to have it 5 seconds.
5 seconds.
He's talking about everything actually as though the Southern Cross is stationary. It's not. We see it moving through the night. So
you see it move this much.
Yeah, but
you see it move a teeny tiny bit.
We don't. No, we see it actually rotate on its axis. You're talking about.
No, you don't. No, you don't.
You couldn't even mention the proper name of octans. You know, the Southern Cross is not the pole.
There is a point in space that the stars consistently rotate around.
Let Dave finish that. No, finish that last sentence. And
yeah, there's a point in space that those stars constantly rotate around. It never changes. It will never change in your lifetime. Whether or not the octans, the Southern Cross is right at that point is irrelevant. It's just another star that's going around that central point.
And on that, thank you for both of our interlocutors. We're moving forward to $5 from Thunderstorm. Question for all three, though it would be all two. What actual shape is the Earth? Is it a flattened sphere ellipsoid? Also, thanks for the debate. Sending so much love, Thunderstorm, and either of you, whoever wants to go first. But what actual shape is the Earth? Is it a flattened spheroid ellipsoid?
The Earth is actually
not both the same.
Yeah, come on. The Earth is obviously has topography. It is the shape that it is of the mountains, the land, the cliffs, the hills, the valleys. It's all those things, but it's all above water level, as we call sea level.
What about the stuff that's under the sea that is made of dirt and rock? That's below sea level. It's below sea level.
Oh, it's got topography.
There's stuff, right. So above sea level has nothing to do with you determining whether or not the Earth is flat or spherical. It just means that as far as you can see, you see water, you see land above, you see land below, and you presume that there's nothing beyond your point of view. And your point of view travels with you, and you assume that it's all flat because that area around your point of view appears flat for you.
And so, Iron, I'm going to let you have one more if you're about to say something, and David one more because it was addressed to both of you, but then we're moving on.
Yeah, for sure. Like, you can absolutely have topography beneath sea level as well. That doesn't prove a thing, but water itself proves the level, and that's how we measure land level is, the land height is above water level. So we don't dispute that there's topography also underwater. There's topography above water. So flat Earth is really, it's a poor name. It's poorly called, and that's why I always use the term stationary planar Earth, because we're not moving. It's a plane that everything's on, and that is our Earth.
And then David, final thought on the question.
Yeah, so the Earth is spherical, obviously, and you see things that you cannot explain any other way. You cannot explain the sun by saying, oh, the sun looks the same size because of personal perspective. You can't explain sunsets and sunrises by talking about perspective doing weird things that perspective doesn't do. Okay? You have all these elements that you put together. You're not answering the question, dude. I am answering the question. He asked what's the shape of the Earth. So the fact of the matter is that when you look at all these elements that are evidence, extraordinary evidences of a flat Earth perspective, of extraordinary evidence of a spherical Earth from a flat Earther's perspective, you end up with a situation of the Earth being a globe. Or you got to come up with 1,000 different other reasons like magic and stuff.
And on that note, $2 super chat from Deej, coming in spicy. The answers are hidden in Iron Horse's hot tub. And unless you have a comment, we are moving forward. Mr. Monster.
I was in my hot tub earlier this morning, but I decided to hop out of it just for the sake of my opponent. Yeah. I don't like to embarrass people too much.
$5
Well,
super.
Hey, guess what? You avoided making a fool of yourself, but you certainly didn't have to embarrass anyone today. Great job.
For sure.
There we go. Last word. Mr. Monster for $5. What do both of you think of the DART satellite that precisely hit a meteor? Is that not evidence of space?
Yeah, I don't believe that there is such a thing as meteors. And the whole evidence of what, something hitting what, there's no evidence of it. We see a lot of CGI sort of stuff, but honestly, when it comes down to actual things in space, it's pretty short and far between on the ground.
So if you have a telescope and you were to see that meteor in the telescope, would you acknowledge that that meteor exists then?
Look, we can talk about all sorts of what if situations, but the thing is, we have to see it in the first place.
Right. So basically, it's kind of like our former president Donald Trump. If he didn't think it didn't happen, but it's only true if he thinks that it's true. Stuff can only happen if you want it to happen. I'm asking you about stuff that we've done, and because I'm not the person that literally did it, you act like everyone else is lying. Everyone else out there who had a telescope who saw that meteor is lying. That's absurd. Well, that's insane.
If they'd like to prevent evidence for it and present it to me,
they already did.
I can try and analyze it and see for myself, but as far as I'm concerned, it never happened.
But what's your level of analysis? Like, you have to literally get into the spaceship and like, oh, hey, you know what? I see it. I mean, you gotta you have to have some concept.
Yeah. Like, everybody can have a body cam. Everybody can have a body cam. Everyone can have a webcam. They can pan around 360. That's never been done on the ISS.
On your period, we're moving forward. $5 coming in spicy. If you argue with Flurfs, I recommend you use SolidWorks / AutoCAD to demo angles, perspective, math, dimensions, and Universe Sandbox to demo the SolidWorks demo.
Man, I'm too lazy to do all that. I will admit, I should have used something like that, Adobe something or other, or Macromedia or whatever. But you know what? This was more than enough. I am very satisfied with the way that I caught him in 2 contradictions. So, I mean, hey, magic, personal perspective. I can't do anything with that with SolidWorks.
Yeah, well, that's the trouble, isn't it? That every single glober has to appeal to some sort of authority, but all they can do then is laugh and mock at the people who use reality, who use a real personal perspective, because that's all we've got. All you've got is your personal perspective, or you've got somebody else's personal perspective if you're going to appeal to their authority. But if you're going to go and appeal to a whole bunch of nonsense that's designed to fit a certain model because that's how they want it to be, then yeah, you're going to live in fantasy land forever.
Am I allowed to rebuttal?
That was my rebuttal.
So you are, because that seems to be technically for you, David.
All right. So you know what he's doing? The Iron Horse, to the audience, what he's doing is he's trying to compare a person's personal perspective, which is simply their ability to see things, with his skepticism, or really his cynicism about anyone else's point of view beyond their sight, beyond their naked sight. So anything that uses a computer, that uses photography, that uses technology, he's skeptical, but he wants you to trust his personal perspective and his concept of personal perspective, and then assume that is sufficient to explain the vastness of the universe itself. Unbelievable. Literally.
And on that, thank you for the continued super chats, everyone. $2 nominal. Can David tell us about the law of dark matter?
No, there's no law of dark matter. What law of dark matter is? Actually, let me look this up. Maybe there is a law of dark matter that I didn't know exists. Because a random person with a super chat. Well, if a random person tells me some stuff that I've like never heard, like law of convergence,
tell you something
law
that you
of dark matter.
Fully believe
Hold on. Let me finish my thing here, bro.
Which depends upon dark matter.
Let me finish my thing.
Can't hear either of you, so pulling you back apart.
Yeah, so let me finish what I was saying. It was directed towards me. So there is no law of dark matter, but the idea of dark matter explaining why galaxies move the way that they do, and why the galactic the way the galaxies all converge and turn into little filaments over the vastness of space or whatever. I mean, that's interesting, but that's not really.
And do they go pear-shaped?
Huh?
And do they go pear-shaped?
Well, if I were to tell you that this, wait.
Waiter.
Hold on. Let me find something that's.
Come on, man. Okay. If you don't understand what dark matter is.
This is not a perfect cylinder. It's slightly oblong. Okay, but the oblongness is probably 1/1000th of its dimension. 1/1000th of its height is oblong from one side to the other. That's all the guy was saying. It's pear-shaped, but the difference between one side of the Earth and the other was by 50 miles, maybe 25 miles, and that 27. You exaggerated because you used the word pear. Just like before you use those other words, you use these words out of proportion to what they're intended to be used.
And we're going to move forward because now I have a question back over to.
Let's get some $10 super
Iron. $5 super chat. Send in love, Sigma. How high up is the huge pocket of helium trapped by the dome where it has been collecting for 6,000 years? Is there a pocket of hydrogen above that?
Who was that addressed to?
That was from Sigma. I do believe that is addressed to you.
Right, yeah. So obviously we've got lighter than air gases. And if they're lighter than air, then that means basically anti-gravity, which means that gravity has no say over them. So if we are traversing through the vacuum of space, then all of these gases are just going to be lost. And in fact, air itself is lighter than gravity. So therefore, all our air should also be lost. But if we use some common sense and realize that we're sitting on the stationary plane of Earth at the bottom of our observable universe, then obviously everything has a density gradient. And if it does reach a physical firmament, as what we believe there is potentially, once it gets high enough that these gases might get so cold that they freeze into a certain form of ice, then the helium itself is going to hit that, and it's going to create a reverse pressure gradient. And that's how we have air pressure on the stationary plane of Earth. We cannot have it on a ball hurtling through a vacuum of space. It just would not exist. It would all be lost.
So
very dramatic, David.
Where's all the helium that people are supposed to be breathing? Like, there should be a lot of helium, and there should be helium vortexes and.
Well, no, you were going to ask a question. So, Iron, answer that question, and then we're moving on to the next.
Yeah, we're moving on.
Obviously, helium is lighter than air, and so where our air is, where our pressure gradient exists, is the air that we breathe in what we call the homosphere, and you know, no intendos intended towards you, Dave.
What about that reverse pressure gradient you were talking about there, buddy? Let's hear more about
now questions can go on endlessly as much as I like them. So we are going to actually move to Sigma. I enjoy this. This has actually been a fun
Sigma
debate.
Is awesome, man.
Another question from Sigma. Iron Horse, help fix our tools. Why can I measure perfectly vertical towers diverging at the top compared to the bottom? Any structures using all tools?
Well, I'd be interested to see that, and if he has some serious results about that, that'd be great to see. Because as far as I know, we've done all sorts of measurements. I would just suggest that these towers are possibly tapered, just like they are on those suspension bridges I talked about. But if you've got some evidence to prove that they actually do diverge, that'd be interesting, because one of the very first things that got me interested in understanding the nature of our Earth in the first place was that we were suspending plumb bobs deep into the earth, a mile deep, and they get further apart at the bottom. So, you know, like this is what got me started on it in the first place over 30 years ago, 35 years ago, is that sort of idea made me start to think. And as soon as you start thinking outside the box of everything that we're told, and if you can appreciate that, then it means that our center of gravity is actually 40,000 miles outside of the Earth, on the other side of it, in every direction. Nothing adds up on the globe, but it still works for a flat Earth.
Man,
I know you're about to say something, but it looks like it's
all
a comment that'll end up being for both of you. $5 super chat. David, just open your blinds. Oh, I'm having fun. Open your blinds so we can see on live stream that it's dark for you and day for him.
Ooh, show more stuff. Hey, before I start doing weird stuff like that, listen. It's funny how you can say stuff and we believe you. We're supposed to just believe that you're telling the truth. Hey, you know, I started flat Earth thinking when I saw two plumb bobs go down into the earth and they were far apart. Everything's the opposite, but we're supposed to believe you're telling the truth. But when we try to show you evidence like photographs taken from far enough away to show the Earth's curvature, it's, well, how do we know that's true? How do we know that's factual? And one thing that flat earthers love to do, they can always just opt out. Oh, believe what you want to believe. It's this, right? If you don't want to believe it, that's fine. Now it don't matter.
And
okay, it's dark.
I want to give you a chance to respond because it does seem like it was a spicy comment towards you.
There.
Yeah, it seems like it's a little bit triggered here. Yeah, I've got evidence for it. I've got evidence for it. I've read the book on my own channel. It's called Secret of the Ages. It's by a person called Brinsley Lepore Trench, and he was looking for evidence of a hollow Earth, and he was actually looking for it going the other way, that it was actually hollow underneath us, as opposed to the evidence he presented, which started to make me think, what if we are on the inside of a massive ball? And the evidence backs the fact that we, if anything, if we are on a sphere, we're on the inside of it, because everything goes outwards. If you use centripetal force to push things outwards, that explains why rain falls down. It's not falling down, it's falling outwards. The water will still find its level. It sort of makes sense. And there are a lot of people who are actually concave earthers. I actually went beyond concave Earth from 30 years ago because I believe that the sun setting itself doesn't make sense. You know, if it sets, it's purely done to perspective. On the concave Earth, it would seem to go back upwards again. So, you know, I just use rational common sense to understand everything. And it's not like I believe
that wasn't rational.
It is rational because it's
what you said was not rational, bro.
The geodetic scientists who did those experiments with the plumb bobs down into the Earth found it got further apart, further down.
And on that, actually, no, I'm going to break up because you allowed me to bring up a sunset question. Not only was it exactly in order, but you wanted that fantastic $10 super chat. Thank you so very much, Bitter Truth, for the support.
Bitter Truth, thank you.
Sunset in USA, same. Time sunrise in other country, then set rise to next country, basically telling us Earth is globe. Iron, you stick on flat Earth. Can you explain why you think that? Let me read that one more time succinctly. Sunset in USA, same. Time sunrise in other country, then set rise. Same time, precisely, to rise to next country, basically telling us Earth is globe. Iron, you stick on flat Earth. Can you explain why you think that?
Yeah, sure. Like, I'm pretty sure I explained this even in the last debate. I was on here the other day with Austin, who, yeah, we basically trounced the globe earthers with that one as well. But it's a simple fact that the Earth is really big, you know, like when we're talking about a 25,000 mile diameter circumference, about the equator, that's huge. Our sight of view from one side to the other is only 4 or 5 miles at the most. So as the sun goes around the equator every single day, then it is basically like the hour hand of a 24-hour clock. So we got our time zones. Where it's above is 12 midday. When it's setting, to our point of view, it's our 6 p.m. Where it gets another 6 hours away, then that's then midday. It goes around and around and around, and it makes perfect sense on the flat and stationary Earth. It makes zero sense on the globe Earth for the very reason that I said, is that if we ourselves are spinning on our axis and going around the sun every 6 months, and we're using a clock, we use a 24-hour clock to measure time every single day. The clock is our fixed position. So if we're 6 months later on the other side of the sun, then according to the clock, our midday must be midnight. It's as simple as that. The fixed mechanical clock disproves the globe Earth as clear as day.
And on that note, thank you so very much, Bitter Truth. But a $5 super chat from Coffee Mom. Can Iron Horse show us a flat Earth model that accounts for the observable facts about reality? An actual model, not an explanation of a model.
Well, it proves itself. The observable facts of reality prove themselves.
It proves itself. Oh my God!
Like how do I present a model that presents reality? Reality exists at full scale.
David, do you have some evidence to back up your claims?
David. Like at full scale, the atmosphere exists at full scale. If I tried to put that into a model, then it would no longer be the same atmosphere anymore. We're talking about something completely different. But at full scale, it works exactly as we observe it.
But you can't apply that thinking to understand the shape of the Earth being a globe. You can't use that same type of thinking that you just described to say, you know what, at full scale, I can understand why I can't really see the curvature of the Earth that is 24,000 miles in circumference from 6 feet high or a couple dozen miles high.
And Iron Horse, it was your question, so it's going to be your final answer. But on that, we will be moving forward. But it's all yours.
Yeah, thank you. Because on that model, then, why are we seeing the same stars 180 degrees away from the sun, looking at night, 6 months later, looking 180 degrees out the other way from the sun? Why are we seeing the exact same constellations that we've seen all year round? Like, we shouldn't. Your globe model just failed on it. Why? Because the whole entire universe goes around the sun as well with the Earth.
No, because the stars are very far away.
That's it. Move on, Amy.
Yep, there you go. Yes. On that note, $5 super chat. Sending love out there once again for not all of our supporters, but our interlocutors for answering these questions. $5 question from Iron Horse. Wouldn't it be weird to fly west from Perth and land in Sydney?
That would be very weird, because we don't do that. When you're going to fly west, you actually fly west and you head towards South Africa. Sydney is towards the east. So if you wanted to fly to Sydney, you'd fly east. And it's got nothing to do with the Earth moving beneath you. It would do exactly the same, using the exact same air speed as the plane is capable of flying, whichever direction you flew. And the Earth is not going to move beneath you.
You don't understand that they use more gas to fly one way than they would the other, though. You think
do
you have gas?
Iron Horse, last
word. Do you have
word.
evidence to support your claim?
Well, it's a question, so it'll go back forth.
Sure. Yeah, let's get the evidence.
Sure, but he doesn't have time to show it, so Iron Horse last time. Right. Okay.
Speaking the same
or at least in that frame of comment.
Call any airline.
Move forward. So we're going to move forward with $2. Oh, the one-liners keep on coming in, but we enjoy the support as well. Taikiti Wahidi debating Russell Crowe on set. Thank you so very much, Decepticons Forever.
I apologize for what I did to you with the last Thor movie. I apologize. We had a lot of potential with Zeus. That's Avengers 285. That's all we had to do. But I wanted to do something different.
And we're going to keep on moving forward. Sigma sending in more love with a $10 super chat. Why does something in a vacuum chamber fall as fast as the same object out of the chamber if there's no air density inside the chamber? If density is a resistive force, what begins the motion?
Okay, then let's just ask or answer that with another question and say then, if we use the same object with a parachute inside of a vacuum, is it still going to have the same resistance as it would inside the medium of air? And of course, inside the medium of air has some amount of resistance and it will fall slower. You do it inside of a vacuum, the parachute will be meaningless because there's no resistance. The resistance is the only force.
May I rebuttal? If the resistance was the only force, then why don't the things fall in different directions inside of a vacuum?
But because of that question, he does have to have the last answer.
I want to have the last answer.
Yes.
What do you mean by different direction? There's a universal up, there's a universal down, and everything universally falls.
Who made that up?
Everything universally falls. Nobody makes it up. That's what we observe. Everything universally falls down unless it's resisted by something more dense than it to prevent it from doing so.
It's the universal. It's the university. It's the universal thing. We don't call it gravity. We call it the universal thing. Okay, gotcha, bro.
And then
universal thing.
Last word, Iron.
Get me, Iron. Come on. Shoot,
no, he's finished. He made a fool of himself. He looks like an idiot.
I sure did. I made a fool of myself.
There we go.
It's the universal.
Sending love to both of our interlocutors, whose links are in the description below. But a 1 million fake dollar super chat from Sideshow Nav. Just like Whose Line Is Anywhere, the points don't matter. You are rocking it, Amy, and from Dinglebungus, Master of Moderation. Thank you so very much, Sideshow and Dinglebungus.
Thank you.
Sideshow.
And Sideshow is amazing. He is the man with a plan you don't see behind the scenes, making our debates fantastic. But yes, going $5 super chat from Nominal. David, how does pressure exist adjacent to a vacuum without the necessary antecedent of a container?
Why do you say necessary? Oh, I know who this person is. That's Nathan Oakley. Nathan, years ago, you tried to debate me on this and I destroyed you in your own chat room. The antecedent is not necessary. Okay, here's the problem that you have, Nate. If you have any force that acts on the gases, if it's electrostatic force, gravitational force, or anything else, that overwhelms whatever sense of pressure equilibrium that you believe has to be the dominant force. So as weak as gravity is, because there is so much matter that is the Earth, that amount of gravitational force allows the air to be adjacent to the ground. That air gradually loses its pressure until it becomes a vacuum. Not the air itself, but the amount of pressure from surface to whatever height you want to say is a vacuum. There's no next to. Next to is an arbitrary concept that you're saying as if that very division line between vacuum and not vacuum is some kind of like something. There's no next to. It's just a gradual reduction in pressure.
That's the most amount of wish-washing, gish galloping I've ever heard in my life.
But it's the truth.
And on that
How
note,
is it the truth?
Oh, you can answer, David,
Yes.
but on that.
He asked the question. So here's how it's the truth. It's the truth because when you go to higher elevations, you measure the pressure to be lower than at sea level, and it's never going to change. The only time that you might see a change temporarily is with a jet stream, but that's still because of the flow of air in the higher reaches of the atmosphere. So
can you reproduce this in a vacuum?
Hold on. So if you're seeing a gradual reduction in pressure as you go up in elevation, why would it stop? Why would you presume that it stops? And there are people who have met, right? So you see that there is there's nothing in the way. There is no dome that's stopping you from going higher and higher. So you end up with a gradual reduction of pressure until there's pretty much nothing. There's nothing up there.
And Iron, I know you're going to want to respond in a second, but what I will say is we are moving into the last stages of the Q&A. It's been fun. If you have any more super chats out there, I will try to get them in, but this is the last warning. Though it has been, once again, not only a lot of fun, but I want to thank both of our interlocutors for joining us. Right back over to you, though, Iron. The spice is real. So after all this, another flat earther still has given no evidence for a flat earth. Shocking.
Yeah, well, he's basically said that you can keep on going up until there's nothing and nothing and more nothing.
Yeah.
But that just doesn't work inside any sort of thing that has a pressure gradient. When you have a pressure gradient, that requires something to contain it. In a vacuum, everything
You're
is
just declaring things. It has to, because you're God. I apologize, oh Lord.
I'm
You're right.
trying to finish my point. Yeah. But yes, what am I doing except declaring things, except for what you were doing? You're declaring that the opposite. You're declaring
I didn't declare. People have gone up in higher elevations and they have seen and experienced a lack of air pressure. What do you want? Are they lying? Are these people lying? All these people are lying when they go up to Mount Everest and the air pressure is a measurable percentage less than sea level. And when the guy goes up higher than Mount Everest.
On a stationary plane of Earth, because there is air itself has density, so therefore it has weight. And so therefore, it will create a pressure gradient.
Iron is going to have...
There is less air above you, so therefore there will be less pressure.
If there's no gravity, why is it above me?
Shut up a second, you for fuck's sake,
hurry up.
What's your problem? So if you're trying to say that we're hurtling through a vacuum of space, then that pressure gradient would dissipate immediately into that vacuum. But when we say that there's just less pressure above us, that makes perfect sense. Okay, now you can rank.
Well, actually, we're going to move forward because that actually was for you, and so you have the last word. So a $5 super chat from Canabear. Celestial navigation elevates angles, prove Earth is measured and navigated as a flat plane. The globe model was created using a flat Earth model.
May I respond?
That I actually think that is for you, so absolutely.
Awesome. So I don't know much about nautical navigational standards, but the little bit that I do know, yeah, that's immature, but whatever. So the fact of the matter is that we started with the presumption that the Earth was flat in the ancient times until people started to do measurements, and those measurements and the consistency of those measurements built upon our observations. Okay, so when you have more observations, hold on,
they
have more observations.
Dude,
come on, man. When you have more observations,
that we started with
when you have more observations,
we assumed it was spherical.
4, 5, 6. When you have more observations and more measurements that back up the previous observations that initially started.
And what are they?
let me finish. That started your insight into understanding that the Earth is round or is a sphere, then the nautical methods that were used preceding are simply augmented by the knowledge that we already have to say, oh, wait, this works. It's like when you have to draw a triangular shape over a vast distance, that triangle's distance, I'm sorry, the angle of each two sides is not going to be 90 degrees. Okay, so when you're trying to measure vast distances from one part of the Earth to the other, you can't use flat trajectories. I'm sorry, you can't use trajectories from a flat Earth to get you from one side of the Earth to the other. In fact, that's why preceding Christopher Columbus and all of that, they couldn't ascertain the distance from one side of the Earth to the other. They thought the Earth was a lot smaller than it actually was.
And so, Iron, it sounded like you wanted. It sounded like you wanted to say something, and then I get because it's David's question. So metaphorically, 30 seconds, and then David 15 seconds, so we can move forward to the last. It looks like 2 questions, but Iron, the ball, all yours.
Go, Iron. Go get him.
Yeah, I was really hoping to hear a coherent argument there, but all you did was
know a lot about nautical.
More gishka.
And you cut me off like 4 times.
Oh, and I'm interrupting both of you.
Yeah, I do believe it was my chance just to have 30 seconds, mate. Yeah, that's all I needed was just to say that you were just galloping. You've got nothing. You don't really know what you're talking about. You're trying to make some sort of coherent argument out of nothing. So, 90 degrees over distance. How do you know what distance, what direction you are going over a very long period, unless you're using a compass? And a compass works in a circle. So, of course, if you're going to make a triangle out of circular edges, of course they won't add that to 90 degrees at each angle.
All right, so here's my rebuttal. First of all, I think I misspoke. I said 90 degrees, but it's really 60 degrees. I believe it's 6, 12, 18. So it's 180 degrees. And that has no bearing on the fact that we're on a 3-dimensional sphere with a curved surface that we traverse as if it's 2 dimensions. The fact of the matter is that you're presuming far too much, and you stop at your presumption, and then when more information is given that refutes your presumption, whether it be nautical knowledge or knowledge of the stars or stuff going over the horizon or whatever, you simply try to reaffirm your presumption by finding some alternative explanation, like personal perspective and
well, thanks so much for doing that.
Some of this is so nonsense I can't even remember what it is. Personal perspective and some other non-existent thing. It's like that stuff. No one can measure that.
And
you can't measure personal perspective.
You're about to have the ball back, Iron, because a $2 super chat from Bitter Truth. Iron, does Earth orbiting Sun or Sun orbiting? That is how it's phrased. Okay. So let me check. Does Earth orbit the Sun or does the Sun orbit the Earth? It sounds like what they're asking.
Fine. Yeah, it's quite obvious that the Earth is stationary. It sits at the base of our existence, and we see the Sun moving around above us, and it takes a very, very big sample. It's very hard for a lot of people to grasp the sense of scale. It's massive, it's huge, but for some reason or another, everybody tends to see the Sun for about 50% of their period of the day. And obviously it's the Sun moving above us. And if we assume then that there is a dome above us that somehow angles that light towards us, it actually works far better than this whole concept of us spinning on our axis to see the Sun.
So I'm going to do a rebuttal here.
So sure, but then it does have to be his final last word because it was.
I think he's just going to stumble on this. So come sunset, if you're here, and it's 9 o'clock, right? Sorry. Let's say sunset, and it's 9 o'clock. So 3, 6. Oh no, actually, yeah. So you're here, and you got to go all. I can't get the thing right, but right here is 12 o'clock. Right here is about 9 o'clock. That's my point. So you're here, and it's 9 o'clock way up here. I should be looking way north during sunset at 9 o'clock. Okay? And I'm not. That's not how it works.
Okay, that's a
Especially when
really
you're close
nice
to the equator.
That's a really nice argument from incredulity, because you just can't quite grasp
There's no
the
incredulity.
whole concept of perspective of how we're looking up.
That's the other thing. Yeah.
We're not looking east, we're not looking west, we're looking
Personal
up
perspective.
to see the things that we see. Yeah, thanks, Amy, for the opportunity.
Absolutely. Thank you both for the responses and the super chat. It looks like we have a tag from Cannabear was saying it was a super chat asking David if he could acknowledge NASA getting caught using wires and green screens and zero-G planes to fake weightlessness. Does he believe CGI is reality?
Well, NASA didn't get caught anything. So let's go over the thousands upon thousands upon thousands of hours of recorded interactions between the astronauts and their zero-G environment. And with that, you don't have green screens. What you have is that's what happened. Now, you might find some specific instance. I remember someone had posted a fake NASA got you video of a green screen, but it turned out that that person wasn't even the NASA employee. It was like a lookalike. And they got busted for doing that. So even if you find one out of the millions of minutes of NASA videos, that's one example that was probably used for some type of mock-up testing or for some specific purpose. But that doesn't debunk all the evidence, not by a long shot. And you don't even have it.
And that begins the last of the three. We just have 2 super chats left. From Deej, flat earthers eat plain cheese pizza, no toppings. And our last super chat of the night, coming in from Dave Gar, and we are sending in so much love right back to him. He is sending for $2. He's saying, thanks both debaters for coming in at the last minute. I could not agree more from my heart and the entire modern day debate community. It has been fun having both of our interlocutors enter the ring and have a juicy debate. Though, I do want to thank you all for joining us here on Modern Day Debate. We are a neutral platform welcoming everybody from all walks of life. If you enjoy this debate, please don't forget to like, follow, and subscribe. It really helps us reach a wider audience on your favorite podcast platform, including tonight's debate on Flat versus Globe Earth with our interlocutors Iron and David.
Longer end of debate, does it?
Woo-hoo, here to help us.
That's the globe.
Find out.
You're
It's
very good at the enthusiasm.
And the globe defenders are just looking like complete idiots.
Yeah, you get past those contradictions, man. Get back to me on that.
You guys can feel the spice. Once again, I want to thank both of our interlocutors, whom you can find in the description below. Plus, if you like even more fun, you can find us out there on the MDD Discord Also, if you ever have an after show, feel free to run, and we'll put it in the description below. Doesn't matter which side. Woohoo! But with that, I am A.B. Newman with Modern Day Debate. We hope that you continue having great conversations, discussions, and debates.
Flat Earth isn't going away, man.